All right, let's tackle this quadratic. It says solve, and you should notice this is a quadratic equation. So anything in the form of ax squared plus bx plus c equals 0 is a quadratic. So this fits that. In this problem, a is 4, so a is the coefficient of x squared, and b is 6 because b is the coefficient of x, and c is 9. So that's a, b, and c. We're going to use the quadratic formula. Here it is. You should memorize it right away, if not sooner. Plug in these numbers in these places, and it looks like that. So I'm doing the opposite of b. Since b is 6, the opposite of b is negative 6. When I substitute b in here, I should put it in parentheses, so it's 6 in parentheses squared, and negative 4 minus 4 a times c, all over 2 times a. So I'm plugging those numbers into this, and that's what I come up with. Now I should do the math. So 6 squared is 36. And here's the way I like to do this. Negative 4 times 4 is negative 16, and negative 16 times 9 is negative 144. So that becomes this. And then you do the subtraction. 36 minus 144 is negative 108. So I need to break that down. I mean, that's basically the answer, but I need to simplify this. So what I'm going to do is separate the negative sign from the 108 and write it like this: negative 1 times 108. Everything else stayed the same. And then everyone knows that the square root of negative 1 is called I in Algebra 2, or if you don't know that, you do now. So I is equal to the square root of negative 1. So that's why I separated this, so I could bring the I on the outside. And now I'm just breaking down 108, which is 12 times 9. So that's the way that looks. So I have negative 6 plus or minus I, square root of 12 times 9 over 8 inside the parentheses. Now I need to break that down further. So that is going to become this. So the 12 becomes 3 times 4, and the 9 becomes 3 times 3. And what I'm looking for here is 2 of a kind. Notice I have 2 of the same kind here. So that I have a 3 here and a 3 here, 2 of a kind. So I'm going to bring that out front. And also the square root of 4 is a perfect root, so that's going to be 2. So I'm going to bring those two things out. So this 3 is because I have 2 3s, or I could say these two. And I have one left over that I couldn't bring out because I'm looking for pairs. And the square root of 4 was 2, so that comes out on the outside also. And in the next step, I multiply those things together and write it like this, so that 2 times 3 becomes 6. So it's negative 6 plus or minus 6i, and the square root of 3 was left over, and it's still over 8. And that's my answer. But if you can take a number out of this location, that location, and this location, you should. And so I took a 2 out of each one of those. 2 goes into 8 4 times, 2 goes into 6 3 times, 2 goes into negative 6 negative 3 times. And so my final answer from this is that. Wow. So that is a fantastic quadratic formula problem, because not only was it dealing with some pretty difficult numbers and we had some pretty significant simplification to do, it even had an imaginary number in there. So this is no average quadratic formula problem. This was above average. So anyway, I hope that helps. Here's what I would say if I went too fast for you. Watch it again and watch carefully until you understand the different steps, because I went through that pretty quickly. Anyway, hey, have a great day. Bye.